Okay, so in this case, we're given integers n, l, and r. So these are whole numbers. I guess, yeah, in particular, they look like they're positive whole numbers. And basically what we're being asked is we want to find the number of ways to represent n as a sum of two integers a and b such that, and here we have a very long inequality, l is less than or equal to a, which is less than or equal to b, which is less than or equal to r. Okay, so let me try to translate this in a bit of a different way. So basically the sum, we want to find two numbers that add up to n, right? If we're representing n as a sum. Specifically, in this case, we want the two numbers, the what do you call them, the summands. We want them to add up, we want them to add up to n, but also we want them to fall within the range, the inclusive range from L to R. So they can be equal to L, equal to R, or anything in between, but they can't go beyond that. So that's what we're looking for. So we look at the example over here, n is 6, L is 2, R is 4, and we find there are two ways of doing it. I mean, technically, there would be like 3, right? Because it could be like 2 plus 4 is 6, 3 plus 3 is 6, and 4 plus 2 is 6. But we consider 2 plus 4 to be the same as 4 plus 2, okay? So we're going to ignore the order sort of thing, right? Doesn't matter what order they come in. That's basically the idea. Okay, cool. So how are we going to do this? Well, basically what I want to do is sort of keep track of the combinations that we're using. So we'll have an object. I'll call it combs, short for combinations. And I guess for now, let's just return this at the end. We'll end up doing something a little bit different from that, but for now, let's just do it like this. We're gonna use our variables a and b. So a is gonna start as 0, and, or actually, it probably shouldn't start at 0 because it might not be able to be 0. In fact, guaranteed it can't be 0 because L is at least 1. So with that in mind, a has to start at L. That's basically the idea. Okay, and we want to keep this loop going. Now, let's talk about the condition in just a sec, but for now, we'll just keep going with this. So what do we want to be doing in here? Well, first of all, let's calculate what b would have to be. I mean, whether or not it's a viable b, like whether or not it fits this inequality or not, we'll figure that out, but we'll just figure out, like, if b is okay, if it will work, well, what's it going to be, you know? So we'll come up with the possible value of b that would make a and b sum to n, and then from there we'll just check if it's like okay, right? So what do we mean by that? Well, okay, first of all, let's just do something like this. If b is less than or equal to r, so you know, if it's falling within the range that we're looking for, we're going to do something like this. We'll say combinations at a is assigned the value of b. Okay, so that's basically the idea. If b is less than or equal to r, combinations at a is assigned the value of b. So basically we're using a as the key for our combinations object, and we're using b as the value for that object. Maybe we'll refine that in a little bit, but for now this is probably okay. Now we don't want this loop to go on forever, right? So we want to give it some sort of condition where it's going to stop. I think I'm actually going to handle it in here. So basically what I'm going to say is if b ends up being less than L, then we've gone too far, right? Because beyond that, like if we keep increasing a, well then b is going to keep getting smaller and smaller and smaller. So if it's already less than L, we've gone too far. We need to stop. So we need to break right then and there. And yeah, I suppose we could probably put these in whichever order, right? Or actually, no. It is important that these are in this order, right? Because if b is less than L, then necessarily it's going to be less than or equal to R. We don't want to be keeping track of it if it's not a viable one, right? So if it's actually outside of the range we're looking for, we should just go ahead and break right then and there. So let's see how this is running. We'll see if it's getting us what we're looking for. Okay, so we're getting the 2, 4, the 3, 3. Now we actually are getting the 4, 2 there, so we'll have to figure out some way of handling that. This one is good. It's just giving us 3, 3. None in that one. I guess that's good. It's sort of what we want. We should be having 5 of these, but it looks like we've got way more. So I guess that has to do with the fact that we're sort of repeating ourselves, right? Like we've got 9, 15, we've got 15, 9, we've got 10, 14, we've got 14, 10. So I guess we could look at the length of this thing and divide it by 2 or something like that, but probably better to just check in here, I would say, to see if we've actually already encountered this number. So basically, we want to break if we've seen this number already, because that would mean, oh, you're getting into the numbers that you've already experienced for A. And remember, A starts at the minimum possible. B is only going to get smaller from there. So if we encounter an A that we've already seen, well, that means every B after that is either going to be less than L, or it's going to be an A that we've already seen. So really what we want to check is, have we found this one yet? You know, have we seen this B value? Has it already appeared as an A value? That's what we want to know, okay? Has this B value already appeared as an A value? So just to use this example over here, right? We've got 2 plus 4. That's an A value of 2, a B value of 4. But if we were to flip it around, 4 and 2, then that wouldn't work, right? Because basically we'd be repeating ourselves, and in that case we're basically saying that the B value would be 2. We've already counted 2 as an A value. So the nice thing is that we are keeping track of all of our A values. They're the keys in this object over here, which is nice because we have a very, very efficient, very shorthand notation for this. So we can basically just say if B is in combs, okay? So in other words, if it's a key within combs. So keep that in mind. In is not the same as like an includes kind of thing. It's not checking to see if this is a value in our combinations object. It's checking to see if it's a key in that object. So really, really important. It's kind of subtle, but very important. Okay, is this working? Yeah, that's looking good. 2, 4, 3, 3. Yeah, nice. Okay, 3, 3, just like we expected. Let's skip down to a more interesting one. Okay, that's good. Ooh, okay, a whole bunch of them. Does that look like 12? I guess we'll find out. Now, this is an object, right? So it's not like we can just do something like this, you know? That's not a method for an object, so it's probably going to give me some kind of error for that. We want this to be an array. Oh, no. Okay, that makes sense. We want this to be an array. So what could we do? Well, could we just convert it to an array and then find the length of that thing? Would that work? Let's find out. And no, because it's not an iterable. Okay, so we can't just spread that out into an array. Too bad. Okay, well, what could we do then? Well, one thing we can use is this this built-in here, Object.entries. Wait, am I using this right? Yeah, Object.entries of combs. I'm pretty sure this is how it works. So basically it's going to make an array out of the elements here. So each of them is going to be a 2-element array where the first or the 0th element is the key, the first element is going to be the value. So basically that's the idea, and we just want to know how many of them are there. So we'll just take the length of that thing. Let's try that. Yeah, there we go. Okay, so that's good. Yeah, that's working. Let's see if it passes all the hidden tests. That would be nice. And there we go. Okay, so that's pretty not bad. Let's close that for now. Hey, thanks. All right, what do we want to do with this? We want to make some changes, I think. So the first thing to note is basically, notice I am checking to see if we've already found this B value as an A. But we're not really using B for anything, you know, like, is it really that important that we have this value here? And even just to illustrate that, instead of entries, let's just do .keys. So now we're not even looking at the value part of it, and yet it still works. So I would argue we probably don't need to be keeping the value of B in here. So maybe there's a different way we can be looking at this. We want an object, but all we need is the keys. You know, we don't need for each entry to be 2-dimensional. We don't need the key and the value. So we're not going to use an object, or at least we're not going to use object literal. We're going to use a set. Everyone's favorite. Okay, so basically we've got a set here, and we're going to have to do this a little bit differently. So we want to check if combs has B. It's our syntax for a set. It's a nice one. I'm pretty sure this is a constant time lookup. I could be wrong about that, but I think that's the case. And here we want to say combinations.add A. Will that work? Oh, it probably won't because of that object keys thing down there. Yeah, we don't want that. What we want is just combinations.size. Would that work? Oh yeah, it does. Okay, I'm just gonna, yeah, for some reason I like it better all squished like that. Up to you, I guess. Anyway, okay, that's cool. I like that a little better. It's nice. I feel good about it. But I want to look at this in a different way. So specifically, yeah, I mean, I mentioned math earlier. Let's do some math kind of stuff. Okay, so we're going to go over to the whiteboard here. I want to start by drawing a number line. So, oh, no, unacceptable. Oh, yeah, okay, that was much better. Okay, good stuff. I'm going to put 0 kind of over here because we're not going to consider anything negative, so no need for 0 to be right in the middle here. We need some pretty cool colors, so what would be good? Oh yeah, okay. Let's get like a really nice green. Yeah, that's probably good enough. And let's make this a little thicker. Yeah, cool. So let's just say, like arbitrarily, we'll say this is, no, not A and B. This is going to be L. And then I guess like maybe over here, we'll say this is going to be R. Okay, so basically what's happening here? What is it that exactly we're looking for here? Well, okay, I'm going to grab another color real quick. Is that? Yeah, okay, that's probably acceptable. All right, so basically the idea is that we're going to have some number n, and we want to find two numbers that are going to add up to n. Now, let's just say, without loss in generality, or, okay, maybe that isn't without loss in generality. Let's just say, for now, that n is an even number, okay? We'll look at the case where it's an odd number, I guess, in just a bit, but first of all, let's just say it's an even number. All right, so if n is an even number, we can divide it by 2, and we'll get a whole number out of that. So let's just say, like, for example, that's where n divided by 2 is. Let's just say, okay? So basically, our A and B could be n divided by 2, right? We could make them both that. A and B could both be this, and that would add up to n. We could make it so that A is 1 less than n divided by 2, and B is 1 greater than n divided by 2. It could be that A is 2 less and B is 2 greater than. But basically the idea is that whatever distance we have here between n divided by 2 and our A value, that's going to be the same as the distance that we have over here between n divided by 2 and our B value. Okay, so so these are the same over here. These are the same distance. And that's an important thing because we're sort of limited here in the sense that, yeah, A could be this one, B could be this one, A could be this one, B could be this one, A could be this one, B could, well, actually, B couldn't be that one. So we have to draw the line there. We have to say, oh, okay, well, you know, even though A can go this distance, which is what, like 6 units, B can only go 5 units. Okay, so basically what we're interested in here is actually like these things, right? We're interested in finding the minimum one of these things. Whichever one of these is the shorter one, is like, yeah, whichever one n divided by 2 is closer to, that's going to be sort of the maximum we can get. So just to back up, let's do like a billion undos here. And we'll say that n divided by 2 is going to be in a different location for this, okay? So, yeah, let's say n divided by 2 is this right here. Okay, so that's n divided by 2. Now, obviously, B could spread right out, you know? B could go all the way over here, and how many units is that going to be? So that's 2, 4, 6, 8, 9. Okay, so that's 9 units away. But the thing is, A can only go 2 units. So because of that, we basically have to restrict this to the case where B also only goes that distance, right? So for example, in this case, what would L be? I wasn't really counting these officially, but let's, I guess, say it's 5, and that would mean R is 16, I guess, unless I made a mistake. So, and then this is what, 7, so N is 14 in this case. Okay, so we're looking for two numbers to add to 14. This is giving us 7, so it could be 7 plus 7. It could be 6 plus 8. It could be 5 plus 9, and that's it. Okay, so it's basically the distance that we have here, like the minimum one of these distances, and then plus 1 because we also want to count this one over here. Okay, so let me know if anyone has any questions about that, about why it's going to be the minimum of these distances, or why we need to put in the plus 1. In the meantime, I'm going to undo a whole bunch of times again, and I want to look at an odd case. Okay, so let's say in this case now, just to pick something close to what we had before, we'll keep this one 5, we'll keep this one, what was it, 16? And then N is going to be 15 in this case, so when we divide that by 2, we get 7.5 for our N divided by 2. Okay, so N divided by 2, 7.5 now. So what do we have over here? This is going to be 2.5. And this was 9 before, so I guess it's going to be 8.5 now. Okay, so obviously the 2.5 is still a lot smaller, but also it's not really going to work as an answer. We're not going to have 2.5 number combinations. It wouldn't make sense, right? So what are we going to have? Well, basically we need for it to add to 15. This is 7.5. So we could have 6 plus 7. We could have 5 plus 8. And that's it, I guess, right? Yeah, I don't think we can do any better than that. So, okay. Basically, in this case, I think, yeah, do we just have these two combinations? Wait, I'm not doing this, right? Those aren't the right numbers. 6 and 7, that's not right. Okay, hold on a sec. 7.5, it should be 7 and 8. Whew, okay. My mistake. Yeah, thanks, Rainbow. So, 7 plus 8, that adds to 15. That's better. Okay, so, I was getting worried for a minute there because that was actually not the right number of combinations that I was expecting. So 6 and 9, 5 and 10. And then, yeah, we can't go any further than that. We can't reduce the A value anymore because then, well, yeah, it would be out of range. What I should have said is we can't increase B anymore, even though it has room to go up to 16. We don't have any more room on the other side. So we're looking at the smaller one of these things. Now, in this case, we had 2.5. And what I said before is we normally want to add 1 to that number. So we could say, like, you know, take the ceiling of this and that would give us the 3. But I think we'll just take the floor and then add 1. So that in either case, we'll be adding 1. That's going to be sort of the idea here. Okay, so yeah, let's get started on that. Let's give that a try. So we'll archive this one. And this is going to be a little confusing, I guess, just because we already have a 2 in here. So I guess, what should we do? Make that a 3? Yeah, I guess so. Okay, and then what are we going to do here? So we'll say middle is going to be N divided by 2, just to sort of get that out of the way so that we don't have to keep recalculating it if we need it again. And then we want to say something like return 1 plus math.floor of math.min, and what are the options going to be? Well, basically it's either the middle minus L or it's R minus the middle, okay? Because we know that the middle is going to be greater than L, we know that R is going to be greater than the middle. Okay, so what did I just say? Oh boy. Middle minus L and then R minus middle, is that what I said? I think so. Okay, so will that work? We're taking the floor, we're taking the minimum of these, we're adding the 1. Let's run it. Let's see if that's working. Oh, okay, 5 out of 6. So it is working in most cases. Let's figure out what's going on over here. Okay, so we're getting a negative value. Let's try to investigate that. So we've got an n value of 10, an L value of 9, an R value of 11. So, okay, I'll try to remember all that. Let's just clear this. Yeah, let's clear it. Let's get started. And, you know, I should have thought ahead. I've got to do a number line again now. Okay, not too bad. Not too bad. I was expecting worse. We'll say this is 0, and what numbers did we have? So n was 10, and then I think L was 9, and R was 11. Let's just verify that. Yeah, okay, cool. So, okay, we'll start with L. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's, whoa. Okay, no, that barely looks like an L. Let's try that again. There's L, nice. And then there's gonna be R right there. And yeah, I think Rainbow's onto something here. Sounds like you got the right idea. So basically in this case, we're gonna take our middle, it's gonna be 5. So where's that gonna take us? Right here. So that's our n divided by 2 in this case. Well, that's no good, right? Because there isn't gonna be anything in here that's going to be between L and R. So we should probably check that. You know, let's just check to see if this actually is between L and R, because otherwise, yeah, it looks like we're going to be getting these weird negative numbers, which doesn't really make much sense here. So let's just do a quick check right here. We'll say if middle is less than L, or if R is greater than middle. Is that what we're checking? No, R is less than middle. That's what we're checking, yeah. If either of those are the case, then let's just return 0. Great, okay, nice. So, awesome, that works. Well, that's a little nicer. I mean, something I like about this is that we've leveraged the power of math here to avoid having to go through a loop at all. So we don't have any for loops or anything like that. We basically just have more or less single calculation. I mean, technically it's more because we're calculating the middle, we're doing this thing over here, and then we're returning this. Could it get any better than that? Well, yeah, I think technically it could, depending on what you consider to be like better. I guess I'll make that 4. Okay, so basically I'll keep this here, like the middle thing, at least for now. Maybe we'll change it after. The thing is, like, if that's the case, like if it is out of bounds here, so to speak, we're gonna get a negative, right? So what we could do is just say, well, if it's negative, make it 0, right? In other words, we're gonna take Math.max of 0, or this number, this result that we would get here. So let's try that. We'll see if that's enough, and yeah, there we go. Okay, so does that pass all the hiddens? Yeah, passes all the hiddens. Now, could we make this better? Well, yeah, we probably could. I mean, we could do something like if you really, okay, let's say you were doing some sort of code golfing challenge or something like that. We don't want to have this here because like it's taking up too many characters or something like that. We could just put in the n divided by 2 over here and over here as well. I mean, that'll work. It's technically fewer characters that way. The other thing to notice is we're using like this math library a lot. So we could do something like let m be assigned the value of math. I'm pretty sure that'll work. I could be wrong, but just a character saving technique, right? We could do something like that. I'm pretty sure that'll work. Yeah, that'll work. I mean, math is basically just a big object, right? It's got a bunch of methods and stuff like that. So yeah, let m be assigned the value of math. That'll work. We could do that. Or I guess it's more like a constant. Yeah, more like a constant. Okay, so is that good? I think that's good. Yeah, it's good. Okay, great. So, nice stuff. Great job on that one, everyone. Let me know if you have any questions, comments, or concerns. And, okay, we do have a question. So Rainbow Sprinkles asked, can't you right shift n? Right shift. Like, okay, wait a sec. Like for what part of this? For this sort of thing, like the division by 2? I'm trying to think, because basically right shifting it would take the floor. I feel like I don't want to take the floor for the n divided by 2. I want to take it after because I don't want did I undo before? Or no, okay, I did it clear. I don't think you can undo that. Basically, like what I'm trying to say is, okay, I will do a few undos here actually. So yeah, let's get that junk out of the way too. Yeah, okay, so first of all, good question. Thanks for asking about the floor. Let's say we have L over here and we have R over here, right? So basically, if we have our n divided by 2 and it ends up like in between like this, right? So if n is an odd number, then I want to know this and this, you know, like I want to know the actual distances from this middle number to L and R. If we take the floor first before doing that comparison, then it's actually going to put it right here, right? So that's going to shrink this distance over here and increase this distance. So that's why I'm doing like the +1 afterwards, so that we'll calculate these things, then take the floor, and then we'll add 1 to it. Because otherwise we'd need to do some checks and say like, oh, well, if it's closer to the left, then we won't add 1. Or then we will add 1. And then if it's closer to the right, then we won't add 1. Something like that, you know? So does that answer your question? Hopefully. Anyway. Yeah, so I think that's it for that one.